Hi everyone, I'm Doug Black, Editor-in-Chief at Inside HPC. We're at the SC23 conference in Denver, and I'm with Ron Renwick. He is Director of Product Marketing at Acronix FPGA company. Really interesting story, really interesting strategies they have in place. So Ron, let's talk about Acronix FPGA technology and generative AI.
A couple of things to talk about there. One is generative AI, and there's ASR, or automatic speech recognition. I think the most interesting thing we're showing at this show is our recently announced ASR solution. So it's a turnkey ASR, automatic speech recognition solution with our partner Myrtle. You get essentially a server, you get a Acronix vector path card, which is a PCIe card with our FPGA. It can do up to, I think it's 1,200 concurrent streams with a very low word error rate. So this is a turnkey solution for like a call center. They can deploy a box with up to 8 Acronix cards in it, get upwards of 9,000 concurrent streams, with trained on multiple models with over 50,000 hours of training time. So this is an inference engine, essentially, a real-time inference engine for automatic speech recognition.
So what does that mean, that number of streams, and compare that to alternative processors and the challenges they face? What's the benefit of handling that many streams?
The number of streams is literally the number of incoming calls. It's how many people are speaking to you. If you look at our demo, and this is also online, there's canned streams where people are talking and the speech recognition tool is interpreting that information and sending it out via text. Other solutions can get into the hundreds, and that's mainly CPU bottlenecked. Our solution can get into the thousands per card. So when you're looking at this is a big CapEx reduction.
Now tell me, another area you guys are involved in is SmartNIC DPU. Tell us about that.
One of the things that people tend to forget about is data has to cross a network. And unless you're a networking person like I am, you just think, okay, I put it across the wire, it gets across the wire. Oh, there's a faster Ethernet speed, so everything's better. The world is becoming a lot more complex. Networks have just increased in complexity, not just from going from 100 gig to 400 gig or next to 800 gig, but the looking through each packet, providing security, inspecting each packet has become quite a burden. And it's quite a burden on CPUs to do that. So what we're offering is what's called the Acronix ANIC solution, which is an Accelerated NetworkInfrastructure Code. The beauty of an FPGA is it's a reprogrammable resource. The beauty of an Acronix FPGA is we have some added functionality on top of that. We have a 2D network on chip that sits on top of the FPGA. Sitting on top of the FPGA allows us to transmit data through the FPGA at 20 terabits per second. Other FPGAs, you have to use the FPGA compute fabric to transmit data. So you're winding up using a lot of precious resources to do networking. With our ANIC solution, what you're able to do is have modular blocks. And those modular blocks are an incoming packet buffer, a rules engine, flow tables, direct memory access to take that information and punt it directly up to the host. And you can add multiples of those in real time because our FPGA, because of that network, is fully reconfigurable in real time. And you can also, there's about 50% of the FPGA left over that allows people to do custom code if you're doing deep packet inspection, if you're doing string search, if you're doing something to enable network application speed, you can do that in the FPGA as well in conjunction with our network infrastructure code.
Okay, now let's talk about Acronix FPGA IP. What does that mean from where you sit?
FPGA IP, that's, a lot of folks think IP, and they think, like ARM processors or something like that. What we have done is when we built the Speedster 7T1500, we built that in essentially a way that the actual FPGA is essentially IP. So yes, we use that and we build the FPGA, but we also sell the FPGA IP. So people can do things like build their own SoC and put an FPGA element in there. So if you're in an environment that has dynamic transcoding requirements, if you're in an environment that has changing needs, an ASIC does not change. Once you've sold an ASIC, once you've built it, it's pipelined. That enables a lot of speed, a lot of functionality there. But if things change, when you especially look at networking as standards change, FPGA IP allows a small FPGA to essentially be embedded in an SoC. And by doing so, you have complete flexibility for that portion of the chip. So you can program that portion of the chip after it's gone out. So if you need to add new transcoding, let's say for some type of AI algorithm, autonomous driving, something like that, you can add that functionality because you've got an SoC that has a slight programmable piece.
Okay, great stuff. So we've been talking with Acronix about their screaming fast FPGA technology. Thanks very much.
Thank you very much, Doug.